Hello everyone, we are from Team Vibhav and today I am going to explain you the basics of deep learning by training a convolutional neural network using Python 3, Keras and Tensorflow. So let us begin. First of all, let me explain you how neural network work. With a high-level example, let us say that we have some input x1, x2 and x3 and we want to map it to some output y1 and y2, let's say a cat or a dog. Now, we want to figure out how to match them. Explanation in a high way. So, there is some connection in between the inputs and the output, which is for now a black box. This black box is known as a convolutional neural network, which is basically convolutions and pooling. So, what is a convolution? A convolution is a process by which a machine extracts features from the image. In the beginning, it finds some basic features like line and edges. After that, it finds curves, circles, squares, etc. And at the last, it finds some complex pattern or faces. Also, what is pooling? Pooling is the method to extract the feature obtained by convolution. Max pooling is the most general type of pooling used. In max pooling, the highest weight which is obtained from the convolutional window is taken out and is saved for the future references of building the neural network. Now, let us code. First of all, we will import some important libraries. Here, we have imported TensorFlow as TF, NumPy as NP, and matplotlib.pyplot as PLT, which are the basics for training our neural network. Now, after this, we are going to import the dataset from mnist, which is a predefined dataset in Keras. This dataset consists of numbers data, lying from 0 to 9. This dataset is divided into two subcategories, that is a training data, test data. In training data, we have divided it into two categories, that is X-train and Y-train. Here X-train are the features which are extracted from the image and Y-trains are the labels associated with the features. Similarly with the X-test and Y-test. Now, let me show you what are the training data over which our image is going to train. Here, as you can see that I have imported image from our dataset, which is black and white in color. This is the actual image over which our data will be trained. The image is initially in RGB mode, which is flattened to black and white. We shall normalize the data by using the following code. In normalizing the data, we will convert the data numbers into a range between 0 to 1 so that our computations will be less. Now, let us build the model over which our data will be trained. So, we will define a variable named model and assign a sequential training model to it. Then we will add three layers in which first layer will flatten the data and second layer consists of a dense layer of 128 blocks whose activation is ReLU. ReLU is defined as rectified linear. And the last layer consists of a dense layer of 10 blocks whose activation is softmax.
Now
Let us define the parameters for our model and train it. The parameters for our model are defined as model.compile, in which the optimizer is Adam and we are calculating the loss in the procedure by sparse categorical catastrophe, and at the output we are seeing the matrix of accuracy and loss. Model.fix train xtrain, ytrain and epoch equal to 4 will train the data 4 times. The number of times you write the epoch is the number of times the data is going to train. Now let us evaluate our data by calculating the value of loss and the value of accuracy over the model which we have trained by providing a new set of data giving x test and y test. Now let us print the values of accuracy and loss. As you can see here, the values of accuracy and loss in the training data and the new data provided differs, as this time the data which we have provided for our new evaluation is completely new to our trained data, so our approximations of accuracy and loss will differ. Generally, the accuracy will decrease by some percentage. Now let us save our model and reload it so that we do not have to train our data again and again. Now let us predict the model which we have trained over a new test model and obtain the maximum of the probability distribution. As you know that the test provided to our prediction is a list and the output calculated is a probability distribution. So we will choose the maximum probability which is obtained from our trained convolutional neural network. After running this, we can see that the output is 7. So we conclude that our machine, which is trained over the set of number, has given an output of 7 with maximum probability for the given input. Let us confirm it by seeing whether the given input was 7 or not. So using pyplot.plt as a function to see the input image, we can see that number 7 was originally given. So this was all in this tutorial. Thanks and have a nice day.